The second part of this question, of this chapter, is the general plane motion. In the general plane motion, guys, I'm going to have both translational and rotational motion. And I have to apply three also equations. And these equations are sum of fx is equal to ma dx, sum of fy is equal to ma dy, and sum of moment around the center of mass is equal to ij alpha. You can also replace the third equation with the sum of moment around any point, but remember, guys, in this case, you have to find, as I said in the video lecture, the moment of ma dx, the moment of ma dy, and the moment of I alpha, or ij alpha, all right? So you can have the sum of moments around P, but this means that you have to find the sum of moments of mag in x and y, as well as ig alpha, all right? So this is for the general plane motion, and don't forget, guys, that if you have any missing equation, you have to go back to kinematics, where you have to apply the relative motion analysis in vector form. Let's say the relation between two accelerations, AA and AB, or AA and AG. Or you have to find out what is your fourth equation if you have a no slipping condition or if you have a slipping condition. Okay, so the procedure of analysis is very similar. You have to apply your inertial coordinate system, show your free body diagram, and then you have to apply these three equations and find out if there is any necessary fourth equation. Okay, so let's start by this example 10. So what I have here, 2 kilograms slender bar is supported by cord BC and then released from rest at A, right? So I know that this beam is released from rest, which means omega 0 and is equal to 0. I need to determine its initial angular acceleration, which means I need to determine the angular acceleration also when omega is equal to 0, at t is equal to 0, at this instant shown here, and the tension in the cord. So I need to determine the tension here in the cord. So of course, guys, this AB is doing a translation and rotational motion. In fact, guys, C is fixed, which means B will do a rotational motion around C, right? So VB and AB are perpendicular to BC. However, A, guys, will have a translation and a rotational motion, right? And I don't know here where is the center of rotation of AB. So I need to find it, guys. I don't need to find IC. I mean, I need to find the equations governing the general plane motion. Now, what are these equations? If I go back to the three equations, three unknowns, so these are my equations, in fact. So let's see if I can apply them. Okay. All right, guys. So in order to do this, let's show the free body diagram. I have a weight here. The center of mass is, in fact, at the center of AB. I have this tension here. All right. And of course, I'm going to have, since this is a general plane motion, this will be AX, let's say, of G, and this will be AY of G. Let's start by the first equation. Sum of fx is equal to magx means that t cosine 30 is equal to m, which is 2 agx. What about the second one? The second equation will give me the t sine 30 minus the weight, is equal to 2AGY. Now what about the third equation, the sum of moment around the G? Of course, this is G. The weight, the moment of the weight is equal to 0. The moment of T is equal to the distance between T and this G times T. Now, it's easier here to have or to divide T into two components, Ty and Tx. Since Tx is passing through G, so it has a moment of 0, and Ty has a moment of Ty times what? Times Gb, which is 0.15. Alright, guys? So I can do this. So the sum of moment around G will give me T sine 30 times 0.15 is equal to Ig, which is 1/12, sorry, m times 0.3 squared plus m, which is 2 times, oh no, why? It's Ig times alpha. So this is the third equation. How many unknowns do I have here? How many unknowns, guys? 2, Kareem? No, I have 4 unknowns. What are these unknowns? T, alpha, AGX, and AGY. So I need a fourth equation. Now, guys, you have to know that the fourth equation could add another unknown. But if I can have a fourth equation that could be divided into 2 more equations, so if I have 5 unknowns, I can have 5 equations. Which means, guys, if I apply the relative motion analysis equation, let's say on this B, why am I going to apply it on this B? Because, in fact, I know that AB is what? AB is perpendicular to BC. Right? It could be in this direction or in this direction. Right? So AB is perpendicular to BC, which means I know its direction. So what if I relate this AB, so let's take it in this direction, this AB to this AG. Then in this case, guys, I can have an equation in vector form that could be divided into x and y, which means I'm going to have 5 equations, 5 unknowns, right? So even if I am adding AB as unknown, however, the equation of AB relatively to AG will give me 2 scalar equations in x and y. So let's apply it. Right? So this is how you use kinematics in kinetics, guys. And I know that AB is equal to AG, sorry, plus what? Plus alpha cross R B with respect to G, which means GB, plus or minus omega squared RB with respect to G. Since I have to find this acceleration at this instant, this means that omega 0 is equal to 0 and this term will vanish. So what is AB? I know that AB, this is the direction of AB. It's perpendicular to BC. So AB is AB sine 30 minus AB sine 30J plus AB sine 30I, sorry, it's AB sine 30I minus AB cosine 30J, all right? Because in fact, the angle between AB and Y will be also 30, 2 perpendicular lines, all right? So AB is AB sine 30I minus AB cosine 30J is equal to AG. What is AG? It's AG x I plus a g y j plus alpha k cross gb. Now what is gb? It's in the positive 0.15 I right? So this means that this one will be what? K cross I is j, so it's 0.15 j. If I divide these equations into two equations, in I, I'm going to have AB sine 30 is equal to what? Is equal to, in fact, AG x. And what about AB minus AB cosine 30 is equal to AGY plus 0.15 j. Right? So here, guys, I added two equations with one added unknown. So I only have one added unknown, which is AB, but I can have two more equations. So if I add these two equations with these three equations, I'm going to have five equations, five unknowns, so that I can find all my unknowns. All right? So if you gather them together, in fact, I don't need AB because the question is to find alpha and the tension. Right? So I only need the tension and the acceleration. So you can, guys, make some substitution and then do the equations, simultaneous equations. So you're going to have that t is equal to 5.61 and alpha will be equal to 28 radians per second squared. Any question? Any question, guys? Okay.